Hello, welcome everyone. We're so excited that you could be here today. We're just going to wait about a minute or two for everybody to jump on here. I see people are starting to. Jarek is in the house from our Adaptive Vision team, and we're excited to get this webinar underway about computer vision and how we can make it easier for you. Give us about 2 minutes here, and then we'll hop back on and start our webinar.
Mm-hmm.
Awesome. Coffee in hand. Are you guys ready? We're going to hit this webinar off and get it underway. My name is Stacy Kruzik, for those of you who might hear a familiar voice. I'm part of the DevRel team here at Zebra, and we're really excited to have Jarek today from our new Adaptive Vision team share his views on computer vision, how you can make it easier for you to develop with some of their software. Just getting this underway, Jarek, if you could just hit the next slide. I just want to invite everybody who is possibly out there who is not part of our community already. I'm inviting you to join. It's free, developer.zebra.com. Please feel free to go there anytime and register and become part of our dev community, and you can get updates on all of our events, blogs, API offerings, SDKs, etc. Everything is in our developer portal. If you want to be part of our newsletter and find out about our events firsthand, there is a link on that page to join and sign up for the newsletter and to learn about the dev events firsthand. We're coming off of a very large DevCon last week. We're really excited that Jarek is here today to explore more about our Adaptive Vision offerings. So I'm going to go ahead and next slide, I think, is coming up here. And I'm gonna kick it off and let him introduce himself and get to know our developer audience. And thanks again, Jarek. Take it away.
All right, thank you very much, Stacy. Hello, everyone. My name is Jarek, and at the Adaptive Vision team, I am a computer vision application engineer. Our Adaptive Vision team is headquartered in Gliwice in southern Poland, and it is my responsibility today to bring you up to speed when it comes to the very rudimentary basics of our most essential product, that being Adaptive Vision Studio. The title of this webinar is Computer Vision Made Easy, and thereby we're going to introduce you to Adaptive Vision software. Some of you may be already familiar with Adaptive Vision software, or perhaps just the machine vision, the computer vision industry in general. Others might not, but I hope that after this short webinar, after this short introduction, all of you will be able to confidently say that you know what Adaptive Vision software may have in store for you and your projects and your clients. So, as I mentioned, Adaptive Vision Studio is the base product of our team, of the Adaptive Vision team within Zebra Technologies. We originally developed our software as an independent company, and Zebra Technologies decided to acquire us as this sort of entry into the wonderful world of computer vision. And I'm going to have this webinar focused on the practical. So we're going to show you a live demonstration of our software's capabilities. Now, as you will soon find out on your own, Adaptive Vision Studio allows for convenient data flow programming by means of functions that are combined in straightforward filter blocks, as you can see on the image here. Basically, if you have a computer vision application, perhaps an application tasked with detecting black traces on an otherwise white surface, you would like to have an application that will first acquire an image, that will then threshold that image for pixel values, and finally extract the those pixels that do not meet the criteria set by you. And that is exactly why Adaptive Vision Studio is such a user-friendly environment. From the beginning to end, I'd like you to focus your attention on the screen here. From beginning to end, you're 100% in control of your application. You know exactly what it does and when, which is why when you need to insert any changes, you can do so easily by simply rewinding your application. Furthermore, our Adaptive Vision library, of which Adaptive Vision Studio is one product of, enjoys compatibility with most available industrial hardware, meaning 2D cameras, 3D scanners, PLC, frame grabbers, you name it. Our library, and thereby also our Adaptive Vision Studio, our graphical user environment, also offers advanced tools for 2D and 3D image processing. And finally, and increasingly more essentially, we also have a vast array of deep learning tools, deep learning algorithms, which is basically algorithms that are based in deep neural networks. And I also hope to be able to show you that in practice today. And so just to give you a quick tour over our software, we may begin our journey with a very simple application, such as a blob analysis. In this example here, we can see that we're trying to find mounts on a white surface. This task is very straightforward, which is why the application is also very straightforward, and it corresponds more or less to the example I gave you a few minutes ago. This is the simple entry into the world of computer vision, and also the simple entry into the world of adaptive vision. However, as we move further and further, we will find that with just as much straightforwardness, we can achieve some really impressive computer vision applications. In this example, we can see the HMI of an application that is tasked with inspecting bottles. All of that was done relatively simply in the Adaptive Vision Studio environment. And this is also showcases just how important computer vision is in the general industry, in every aspect of life that you can think of. Here, the task is to detect the level of liquid in each bottle. We also need to count how many bottles there are. We need to know whether the coil inside the cork is twisted properly, and whether there isn't any foam floating inside the bottle. And this, on the image here, you can see that the first 3 bottles were analyzed to be correct. And the fourth bottle, on the other hand, failed the inspection due to numerous factors. And this application too is very simple. Both this and the one before, the mounts example, you can actually have a direct look at yourself if you decide to try out Adaptive Vision Studio, and to which I greatly encourage you. And finally, we have our deep neural network based solutions for, in a way, complex cases. And here we can see an example of deep neural networks being applied to counting objects, in this case bees, on a background that can't be described exactly as uniform. This is a task that would be very difficult, if not downright impossible, to achieve via traditional computer vision methods. But our deep learning algorithms indeed prove that this is the case. And again, I hope that I will be able to show you that in a few minutes. And yeah, so just like I promised, we're going to now try it out. We're going to see just how Adaptive Vision Studio works in practice. So I'm going to shut the presentation now and open the Adaptive Vision Studio 5.1 Professional. 5.1 at present is the most current version of our software. I hope that my screen remains visible to you. If there are any trouble, I trust that Stacy will let me know. Now, what we are going to do here, we're going to prepare an application that will just like we just saw, that will detect spacers on a white background. So spacers that are being lit from below and captured by a camera mounted above them. And first, I will just let you have a look at it. Have a look at the setup yourselves. So we're going to use a block to acquire the image from a web camera. Here, this is one of the first filters that we encounter. I'm going to set the index at 1. I'm going to drag the output frame onto the preview window and hit play, and now we can see a live image of the setup, at least part of it. So what we're going to do is we're going to be looking for these spacers. These we're going to use just one application to find all of those spacers whenever they may appear. So we're going to shut down the application now, and let's build our program. I'm not going to be explaining every single thing that I do as we go through the application building process. The exact details we'll of course be able to explain whenever you pose any question. However, I will try to make sure that you can follow the general guideline. So first, I'm going to be capturing an image coming from the camera mounted above. It's actually, let me just show you this camera. This is sorry, it's a little, but the camera is right here. Apologies about the quality, but it's just a webcam. And of course, we're going to be we now need to capture the image coming from the camera you just saw. So let's hit stop again. Let's find the Genicam filter grouping, because this camera is reliant on the Genicam standard. We're going to first start acquiring the image. We click insert and we put it in the initialize section, just to make sure that this function, this set of functions, this filter will be executed only once at the beginning of at the first iteration. We're going to select the address of the camera shortly. And now let's once again enter the Genicam filter grouping. Now that we started acquiring the images, we need to grab them as well. So let's grab them synchronously. And let's put this filter here. And once again, it requires a camera address to be specified. So let's do just that. Let's select the USB Vision based camera here as well. And let's see if I will be able to see the frame. Yes, we can see that the frames are being captured. And let's now enter the backlight. Yes, we have our backlight. Yes. Now we have the setup all ready, and like I said, we're going to be looking to find those spacers, regardless of their size. So let's shut the application now, and now we're going to threshold the frames that we're getting. So let's move down. Let's enter the image processing grouping, and let's find the threshold image grouping, and let's threshold the image on the basis of its intensity. Let's connect the frame output to the in-image input, and we're going to be looking for not at least 128, but at most 100. And let's see how it will work. Yes, as we just saw, we were able to successfully find the spacer, and let's see some others. And however, as you can see, sometimes there may be other pixels that will be thresholded, and we don't want them. So let's make sure that all we capture is the biggest blob of this region that we get. So we need to split this region into blobs on the basis of its size. So let's go now to region analysis. Let's split the region into blobs, connect the region, and we now know that we have numerous blobs here. They pop out differently. I think I need to move the camera a little bit. Yeah, and now it's more or less stable. But if there's anything popping out in the field of view, it will still be detected, and we don't want that. We don't want anything else except the spacer. So let's find the biggest blob. Let's find the biggest blob which will correspond to the spacer. So let's enter logic and math. Let's find the array grouping, and let's find the maximum element. And we need to choose the data type region. Okay. Let's have all the blobs in this array, and also we're going to use the value of their area. Let's make it or nil, just so we don't get any surprises. Let's play. And now we get only one element. Let's see, it doesn't care about my finger here. The only thing necessary here is the spacer. So let's stop this thing. And now we're going to surround this spacer with a rectangle in order to get a proper coordinate system. Why? We'll see in a second. So let's get back to the region analysis by means of region feature. Let's find the region bounding rectangle. We're not going to make it standard and safe. We're going to make it fixed angle or nil. You don't need to worry about exactly the details of it. Just like I said, everything can be explained further down the line as you also get more experience in it in Adaptive Vision Studio. And now let's see. Yes, we get our rectangle, and now we need to use it to get our coordinate system. So let's go to Geometry 2G. Let's create a coordinate system from rectangle. We connect the rectangle and we'll get the coordinate system once again. We do get our coordinate system all right. And now we're ready to fit a circle around the spacer. I'm not sure if I specified that this is actually our task to surround the spacer with a proper circle, which is exactly what we're going to do. So let's hit stop. Let's get to Computer Vision 2D. Let's find fit shape grouping. Let's fit a circle two edges. We connect the out frame output to the in image input, and we now have the in fitting field alignment that we can connect as well. We need to perform one iteration that will return some warnings, but we don't need to worry about them. And now we're ready to prepare the in fitting field. So I'm going to create this kind of circle that will be as flexible as it gets. And I hope that it will suffice for whatever position the spacer might find itself at. Okay, so let's find the circle. But we don't want that inside, we want that outside. So let's change the edge transition from bright to dark to bright. And now we get our circle. Circle around the spacer. It may not be always perfect, but it should suffice. So now let's see some other. We get the circle around the spacer. Let's see this one. It works as well. This one is completely different, but it too was successfully found. Even though we based the shape fitting on a single spacer, it seems to fit every single one of them. Now, let's have a look. Let's put this all into a human-machine interface for easier analysis. So let's hit stop. Let's open the HMI editor. And in this is the place, this is the canvas upon which we will prepare our HMI controls. So first off, we want to be able to see what we're inspecting. So we need to have the camera output, the camera stream, visible on the HMI by means of the view to the box filter control. I'm sorry. Let's make it big enough. Let's make it the initial size mode fit to window. And what we want is not just for the original, the raw image to be displayed, but we also want the circle that we found also displayed here. So let's connect this. And also perhaps if we open the additional ports, we can find the center of the circle. Let's make it visible as well. Let's open this up a little bit. Let's see how it works. Yeah, I'm sorry, I forgot to connect the out frame output. Yes, and we can see that the circle is marked here just as we wanted it to. However, it seems that the line width could be increased a little bit for clarity. Let's see. Yes, and now everything is plain visible. Finally, we want to also output some values, some actual values. In this case, let's say we want to know the spacer's radius. So we can once again find out the out circle output and find those sub outputs, in this case radius, and we will return a string value. So we want to output that radius value onto an HMI control that will display this value. So let's open the controls. Let's find label. Just in advance, let's make the font a little bigger. Let's make it 15, that should suffice. And let's now connect the out circle radius value to the control. Let's hit play. As you can see, the radius value keeps changing because at any single point in time, the detection is slightly different. It always will depend on your camera setup. This one's obviously also not perfect, but more or less we can say that the radius of this spacer amounts to 168 pixels. And that's pretty much it when it comes to building your first application in Adaptive Vision Studio. We can actually add another view to the box control just to be able to also simultaneously control the view in the, so to speak, real world. Let's output the web camera frame here. Let's also make it fit to window. And now for the final test. It is found. It has to be seen in its entirety. It is found. It is found. This one's now found instead because this one's bigger than the other one. This one's substantially different than the others because it's rather thick as opposed to these. So yeah, that's it when it comes to our circle finding application. And finally, I want to show you also to give you the taste of our deep learning algorithms based on the simplest of those tools, that being deep learning based optical character recognition. You may have seen it on one of the slides before. So let's stop the application. And now I'm going to remove all those filters. We don't need them anymore because we're going to be now doing a completely different application. And what we're going to be doing now is, if you pay attention at the, let me just, I needed to get us some light. If you can see, perhaps I need to change the lighting here. Yeah. We're going to be inspecting such a package for characters. You can see it on the webcam or directly for the camera, for the other camera. And I will show you just how we can do it. So let's stop the application again. And we're going to be using one of our deep learning tools. Let's get back to the toolbox. Let's find the deep learning grouping. First, we need to deploy the model. In the case of the deep learning OCR, deep learning read characters, you can see a few others as well. We need to deploy the model, even though the model is pre-trained, we need to deploy it as well. So let's find the read characters deployment filter. Let's put it in the initialize section, maybe here. And we're going to now put the read characters filter in the process section. We of course connect the out frame output into the in image input. So let's hit start. And we need to wait for the deep learning model to be deployed. And now we're going to set the excuse me, region of interest. We're going to be looking for these. Let's see how the model will fare against this task. We lost the other data, obviously, when we deleted the filters. So now let's have the out characters. Oh no, I mean out characters boxes. Yes. Let's hit play. And let's see. Well, here we don't actually have the values, but we can, maybe we're going to, for the time being at least, let's put the values for now. Let's have a look at the character boxes. And yes, we can see the results right here. We can see that it was all detected correctly. But we can also have a look at here, at this serial number here. We can see, however, that one thing is missing. We don't have the column here. But the only reason why we don't have it is because we need to set it in the in character range, because sometimes you don't need columns. The columns may only confuse things. But so let's add a colon, and now it actually appeared. And this is actually the deep learning based optical character recognition is one of our newest tools that replaced the traditional traditional method based optical character recognition, and it's something that we're extremely proud of, and it's just a taste of what the wonderful world of deep neural network based algorithms have to offer. So let's see if they, oh no, I need to play it. We can see that I think because I need to stand within the region of interest that I set. We can see that the detection remains competent even when subject to quite a bit of search. I don't know if you noticed that I'm squeezing the bag. No, maybe like this. It will be easier to. And despite being subject to so much strain, the detection is still competent. Yes, and that basically sums up the application I wanted to, the applications I wanted to give you the taste of. Perhaps I could also, let's hit stop. Perhaps I could also give you an example of the B detection application you saw on the slides. This is, I may have slight compatibility discrepancy, but it shouldn't be a problem. And this is actually the example of the B detection application that we saw on the slides. As you can see, quite impressive. And all of that was based on a relatively simple deep neural networks based model. We can also, yes, Stacy?
Just want to interrupt to let you know we have quite a few questions and stuff. So just a quick update for anybody. If you have questions, post them in the Q&A window, and when he finishes up, we'll go through all of them. Okay.
Okay. So let me just real quick. Let me just show you the other example we also saw, the one that is based on the that's based on traditional machine vision algorithms, and we can see this in action. As you can see, all of that was done in a relatively simple application like this. Of course, it's not even as simple. It's not even as simple as the deep learning applications that we also saw are composed mainly of 3, sometimes 4 filters, which is a great showcase that Adaptive Vision Studio is for everyone, regardless of how much exposure they have had to machine vision before. Okay, Stacy, I think that just about sums up what I wanted to say. And
oh, this is really great. This is good information, and I think we have a nice audience here. Felt some good questions coming from them. I have a first question, which has been up there for a while, and we can address, of course, is do we need a license to use Adaptive Vision Studio?
Let me put it this way. You do not need an Adaptive Vision Studio license to have a taste at our software, but we generally recommend that you apply for a trial license, because we have a version of our software that's a little bit more limited, that is not based on licenses, but which will usually distribute to students, to people who are not interested maybe in commercial projects, who maybe do it for education. You, I'm sure everyone who's attending this webinar, if you register on our website and apply for a trial license of our software, you will get it and you will be able to practice yourself for however long you need, because that's our policy. We don't guard our licenses. We don't keep our licenses so close to our chests as some of our rivals and competitors do. We want everyone to at least give Adaptive Vision Studio a try. And we welcome all of you. Just write to us or via Stacy, via the means of communication that you were provided, and we'll definitely be able to establish some fruitful cooperation. So no, don't be shy, just register, ask for a trial license, you'll get it.
Yeah, and we can address that too at and it's not up there, but we have our email, developer@zebra.com. You can definitely email myself and the team, and I can make sure that Jarek here gets it. We're in the beginning stages of this, as he had shared, because we have just purchased Adaptive Vision, so we're integrating this all into our portfolio. And so your feedback is really helpful here as well. So we're gonna really take that under consideration. So please make sure if you have any other additional feedback or questions, you can always email us directly at developer@zebra.com. There's a couple of other questions here I wanted to get to. How does barcode detection work, and does it use deep learning?
Okay, so barcode detection, it is provided by Adaptive Vision, and I think the screen is still being shared, right? I could just hop into the example for barcode detection.
Yep, yeah. We can see it.
And so this would be barcodes, of course. This is not based on deep learning, okay? But we can see that the text here is decoded is here. We of course have the same, have also corresponding filters for data matrix and QR codes. Here you can just get some examples, but again, this is all based on traditional machine vision algorithms, meaning that depending on the format, as we can see, we have quite a few formats to choose from. We can also automate it, make it so it will be detected automatically. However, we generally recommend that if you know what you're dealing with, you probably should choose the proper barcode format in advance. But again, no deep learning here. So it's available in our product in its very basic form. Okay, so.
Okay, and so let's get to the next question. I can read this here. Can you use this service through the web API?
Not at present. Right now, Adaptive Vision Studio is requires being installed, run on site. But of course, we are also investigating this aspect for the future. For now, however, no.
Okay, let me just see. If
no, I'm sorry. Of course, it's fine.
Make sure I understand this correctly. Does the ABR decoding use the open source decoder algorithms? I don't know what the ABR.
Come again. Well, come again with the question.
Does the ABR code decoding use the open source decoder algorithms? Sorry, can't talk today. I'm not sure I understand the question. Maybe it's barcode.
Okay, perhaps no. From what I understand, every single one of our barcode detection works on is our own in-house developed. It's not based on any open source solution.
Yeah, it was barcode reading. I'm sorry, it was a mistype, and I just didn't read it correctly.
Okay. I'm sorry.
That's okay. I think that's it, and that's all we have right now. So if there's anything else for our audience, if you guys want to post that up there. Otherwise,
well, all I can say,
words?
Once again, encourage everyone to go on our website.
Do you want to post that for them? The URL.
Perhaps I will just show everybody.
Page, right?
Yes, I hope that I can do so.
See if I can get this for them. Hang on.
That I don't have.
I'll post it up in the page here, but
I think I might have trouble with the, obviously not with the internet connection, but I seem to have trouble visiting sites right now. I'm not
No
sure
worries.
why.
I've got it posted for you. And then again, if there's any other questions or you guys come up with anything, please email us at developer@zebra.com. It looks like we have one last question here that just came in.
Yes.
Does the trial version include the deep learning filters?
It depends on whether you actually need to try out deep learning based tools. We are 100% open to it. If you tell us that your project may require deep learning, or that you simply want to just know how our deep learning tools compare against competitors that you may have been exposed to, then by all means, we'll provide you with a trial license that will cover the deep learning tools as well. So it's just a matter of, of getting in touch with us and talking to us. Even though we're now part of the big Zebra Technologies, we still maintain this in a way startup spirit of struggling to be in direct touch with our partners, with our users, to maintain this relationship between us and them. That's what they appreciate. That's what we like as well. So we do hope that as you communicate with us, we just simply know each other more as people, and that every once in a while we may actually stumble across one another on some expo or something. So definitely, by all means, don't be shy. Just write to us if you have a project that you like to try deep learning on. Just write an email. We'll settle things for you.
Yep, absolutely. We're happy to do that. So with that, I'm going to wrap it up today. Again, any questions, email us at developer@zebra.com, and follow our information on our developer portal on zebra.com. You'll see a lot of those offerings coming through soon. So, and we're going to plan on doing some subsequent Dev Talks next year with the Adaptive Vision team. So watch for those and make sure that you subscribe to our news and events. And with that, we're going to sign off and sign out and wish everybody a wonderful day and a safe one. And thank you all for attending.
Absolutely. Thank you very much from me as well, and from the whole Adaptive Vision team. And thank you, Stacy, for hosting.
Absolutely. Thanks all. Bye-bye.
Bye.